morning everyone. I am Bharat, the leader of Team Sam Research School. Here is my all meeting. Here is Sugin Sina, Sidesh Mazumdar, me, and Dhruv Kushma. So let's start with our problem statements.
So let's start with the problem statement. The first problem is range due to poor charging access and no fault line. Blocks EV adaptation, especially beyond metros. Second problem is long charging time. Long charging time and limited fast charging infrastructure make EV less practical, showing adaptation. Third problem is grid instability. Grid instability means unpredictable voltage, outages and transformer overloads that make EV charging unreliable and risky, especially in rural and semi-urban areas. Fourth problem is heat and dust damage. India's harsh climate, heat, dust, and poor adoption reduces EV lifespan and raises maintenance costs. Fifth problem is sparse charging infrastructure. Sparse and uneven EV charging infrastructure, especially in rural and apartments. Heavy areas limit practicality and slows mainstream adaptation. Sixth problem is high battery cost. Imported battery packs and starts raw materials drive up EV cost in India, limiting accessibility and research. Seventh problem is low public awareness and identity mismatch. Low awareness and weak emotional alignment make EV less impractical or uninspiring, slowing adoption especially among aspirational buyers. Eighth problem is lack of skills data. India's EV growth is slowed by a skill gap. Mechanics training, ICE lacks expertise in EV tech and.
Thank you, Siddhesh. So, welcome to the new era of EV with a new revolutionary technology, the Racer Pulse Core Tech. So, let's get started.
Now let me introduce to the Racer Pulse Core. It looks like basically a traditional internal combustion engine, but basically runs on electricity. Sounds like illogical that how can an engine work on electricity? But yes, it works. Usually we have heard of solenoids, a loop of wire that can generate magnetic field inside it. Let's say if we kept a magnet inside it and turn the flow of electricity to the solenoid, it will create a magnetic field, making the magnet move in one direction. Now, what is the use of solenoid? As we previously in IC in engines, there are fuel systems, spark plugs, camshaft that burn the fuel in the cylinder, create a blast and make the piston move. Similarly, the solenoids here are used as spine pumps that pushes the magnetic piston downwards, making the crankshaft rotate. Now, magnetic pistons. We usually hear about pistons. As we mentioned in the solenoid topic, pistons are the parts that help to generate the torque through the crankshaft by having a linear movement. It goes up and down. Why? It's similar like riding a bicycle. Here the paddles and crankshaft and the pistons are legs. This movement helps them easily generate torque. Now here is the image of a crankshaft. You can see that the pistons are connected with the crankshaft that helps to move the crankshaft and produce torque. Now let's bring it to real life car implementation. So we have taken our sample model, our design, Sam Legacy Light GT. We have chosen this as its manufacturing cost is low, especially it has a powerful engine that will help us to realize high power performance. So here are some images of our car. It's like the front part, the rear part.
Now we have made the car, but still there's a question: why are we using an engine that runs on electricity? The main reason is that it supports our regen tech. Now let's know what's our regen tech and what's in it and how it supports our RBC engine.
So now let me introduce to our next part, pulse code regen system, parts and modules. Basically, it has the following parts: braking regen, wheel generator, R-carrier means included in engine and gearbox, TEG module, solar roof, dual capacitor system, idle traffic regen, ECU bus logic and battery buffer logic. These basically each contribute to 10 to 25%, 4 to 8%, and like at the end 3.5%.
After integrating all these system parts, we can regenerate up to 37 to 67%. And after all, we can successfully make the most revolutionary EV that born from cross of two successful tech. And this way we get SAM laser pulse coated. Our team also have developed a website to calculate torque and horsepower dedicated to our technology.
So you can see here, this is our 3D model prototype. Here is our engine. You can completely see up here. Like I can segment the parts. This is our main engine block, where we are gonna attach the solenoid in this cylinder. Here we can attach the solenoid bobbins up here. Now this is the magnetic pistons. In this pistons, we will attach magnets on the top of it, so that the magnets can be easily repelled. Now this is known as crankshaft. Now this crankshaft will rotate through this magnetic piston movement, so that we can easily generate torque from this high end. So this is our prototype.